guys. Let us move for the next topic in this video, that is selection rules. So these my videos are useful for PG students, degree students and who are writing set or net. Okay. So first selection rules. Okay. So now here we know that in an atom there are number of energy states. In my last video, we brought that particular energy states. Okay, splitting of the spectral terms. So it is observed that the transition between the different energy states do not appear. Only few transitions are possible and that are governed by certain rules. We call it as the selection rules. So first, the selection rule for L, orbital angular momentum, we write it as delta L plus or minus 1. Only these transitions are possible. Similarly, we will write the selection rule for J. Delta J is equal to plus or minus 1 or 0. Right? Similarly, the selection rule for S. Right? Now for S, we will write it as delta S is equal to 0. Right? These we call it as selection rules. Now in presence of magnetic field, we will write it as delta ML is equal to 0 or either plus or minus 1. Delta MS is equal to 0. Delta MJ is equal to 0 or plus or minus 1. So similarly, like selection rules, we will have intensity rules. Right? So for intensity rules, if delta L equal to minus 1, delta J is equal to minus 1, both are of same sense, minus 1, then we will get most intensified line, the transition line or spectral line. Right? Now, if delta L is equal to minus 1, delta J is equal to 0, we will get less intense spectral line. If delta L is equal to plus 1 and delta J is equal to plus 1, we will get weaker spectral line. If delta L is equal to plus 1 and delta J is equal to 0, the decreasing, 1 to 0, we will get weaker line. If delta L is equal to minus 1 and delta J is equal to plus 1. Similarly, if delta L is equal to plus 1, opposite sense, delta J is equal to minus 1. In these two cases, there will be no transition. We will not find any transition of electrons from lower energy level to higher energy level. Right? Now, next, here to understand these selection rules, let us take the example of the fine structure of H alpha line. You will understand about these selection rules. Okay, how many transitions are possible and how many will appear depending upon the selection rules. Right? Now here, these all spectral lines arise due to transition of atoms from one spectral term to the another spectral. That transition may be from P to S, D to S, D to P, in such a way, from one spectral term to other spectral term. Right? Now, if we take the example of hydrogen, only one valency electron is there in hydrogen atom. And that valency electron will give the complete structure of this splitting of the spectral terms. Right? If we take sodium, So in case of sodium, so 10 electrons are interlocked and only one valency electron is there. These interlocked electrons will not contribute any angular momentum. Only this particular valency electron will contribute the total angular momentum of an atom. So the valency electrons contributes the total or explains about the total angular momentum of an particular electrons. Right? Now next, let us take the example of this H alpha line. So now H alpha, according to Bohr's theory, here H alpha line is nothing but the first of Balmer series. And Balmer series means what? Here the electron jump is taking from n is equal to 3 to n is equal to 2. Balmer series means nothing but electron jumps from higher energy level 3 to next lower energy level 2. N equal to 3 to n equal to 2. Now let us write the spectral terms of H alpha line. Right? So first let us write for upper state. Upper state. What is the upper state? N equal to 3. Right? So now here first we are writing the total angular momentum L plus or minus S. Okay? And first here I am writing L values. Here I am writing L plus or minus S. Now upper state n equal to 3 we are saying. N equal to 3 means the 3 possible spectral terms are possible. Okay. 3 means what? So what will be that possible values? 0, 1, 2. For n equal to 3. The 3 possible spectral terms will be 0, 1 and 2. Right? Now, S value, half. So, first, for 0, for L equal to 0, S is equal to half. What will be the J value? 0 plus half, half. Now, here, what will be the J value? Plus or minus S? No. So, here separately I will write. Here I will give a perfect value. First, L values. 0, 1, 2 and J values L plus or minus S. So, and with L equal to 0, S is equal to half. J value, if you do plus 0 plus half, half. If you do minus also, what you will get? The same half value you will get. So, half. Now for L equal to 1, J value 1 plus or minus half. Now with plus 1 plus 1 by 2, 3 by 2. With minus 1 minus 1 by 2, 1 by 2 you will get. So the maximum value is 3 by 2, minimum value is 1 by 2. Similarly for L equal to 2, now J equal to, now 2 plus or minus half. For plus, for first let us do minus. 2 2s are 4, 4 minus 1, 3. 3 by 2 is the minimum value. And maximum value 2 plus 1 by 2. 2 2s are 4, 4 plus 1, 5, 5 by 2. So the spectral terms 3 by 2, 5 by 2. For this is for n is equal to 3. Similarly, so Balmer series 3 to 2 we said no. Let us write for n is equal to 2. Right? Let us write for n is equal to 2. So for n is equal to 2, what will be the L values? Only 2 spectral terms will be there, 0, 1. And what will be the J values? So first for L equal to 0, J equal to 0, plus or minus S is half. So either plus or minus you will get half only. Now next for L is equal to 1, the J value will be the same value, 1 by 2. Or you can write first maximum value, then minimum value. 1 by 2, 3 by 2, 1 by 2. Here also 3 by 2, 1 by 2. First I am writing the maximum value, 5 by 2, 3 by 2. Right? Now let us see how many transitions are possible from n is equal to 3 to 2. Here I am writing 3. First I am writing 1 by 2 for n equal to 3. 3 by 2, 1 by 2. Right? Now how we will write this one? Next, sorry, 5 by 2, 3 by 2. First, L value 0. For this only, no? 0 means what we will write? Yes, again I am writing L. 0 means S, 1 means P, 2 means D. Correct? Yes. Now next, what is the J value for S? 1 by 2. Now what is the multiplicity? 2S plus 1, no? 2, 1 by 2 plus 1. 2 strikes of 1 plus 1, 2. Multiplicity we will write here. Similarly, next what we got? This one. Right? These I am writing. Now L equal to what? 1. 1 means what? P. Here also I am writing P. J value. Here we will write as subscript. And 1 by 2. Sorry. Multiplicity as usual 2. Now next this one. 2 we are having. 2 means what? D. Right? First J value 5 by 2. Here 3 by 2. Multiplicity as usual 2. Right? Now similarly for n is equal to 2 I am writing what we got? 1 by 2. Right? And 3 by 2. 1 by 2. First 1 by 2. 1 by 2 for L equal to 0. L equal to 0 means what? Yes. 1 by 2. Multiplicity as usual. What will be multiplicity here? 2. Sorry, S is ground state. So in multiplicity we will substitute 0. Here 1. If we substitute 0, we will get 1. Here also 0. Sorry. 0 ground state. Now here from here, these are not ground state. So S is equal to half only we will substitute. Now 3 by 2, 1 by 2. For L equal to 1, we got these spectral terms. L equal to 1 means what? P. 3 by 2, 1 by 2 J values. And multiplicity. What will be there? 2, 1 by 2 plus 1. 2 strikes off 1 plus 1, 2. Multiplicity is 2. Right? Now we wrote the spectral terms. Now let us see the transitions. No? First I am writing n equal to 3. Next here I am writing n equal to 2. Here H alpha line means Balmer series. Balmer series means n is equal to 3 to n is equal to 2. The transition takes place. Right? First I am writing n is equal to 3 terms. 1 S 1 by 2, 2 P 3 by 2, 2 P 1 by 2, 2 D 5 by 2, 2 D 3 by 2. And n is equal to 2 values I am writing. 0, sorry not 0, 1. Multiplicity 1. 1 S 1 by 2, 2P 3 by 2 and 2P 1 by 2. Now see how will be the transition. First this may go to here 1 in such a way 2, 3, again 4, 5, 6. Again this also. 7, 8, 9. Again 10, 11, 12. Again 13, 14, 15. So theoretically, how many transitions are possible? 15 transitions must be there. How many transitions must be there? 15 transitions must be there. But these 15 transitions are not possible. So here, now we will apply selection rules. And we will write the transitions. Now let us apply the selection rules. So once let us I will remind what are the selection rules. So selection rules, first for L plus or minus 1, and for J either the value must be 0 or plus or minus 1. Now once again to write the selection rules, I am again writing these spectral terms. So first for n equal to 3, n equal to 2. For n equal to 3, what we got? 1 S 1 by 2, 2 P 3 by 2, 2 P 1 by 2, 2 D 5 by 2, 2 D 3 by 2. And for n is equal to 2, we got 1 S 1 by 2, 2 P 3 by 2, 2 P 1 by 2. Right? From n equal to 3 to n equal to 2, transitions are taking place. Theoretically, 15 transitions we got. Let us see based on selection rules whether 15 transitions will be there or not. First, let us check L value. Here again I am writing L. 0 means S. Okay, spectral notation. 1 means P. 2 means D. First, S. So, S means what? 0. 0 minus 0. Delta L value becomes 0. If you do 0 plus 0 also, delta L value is 0. But whether the selection rule delta L equal to 0 possible? Not. Delta L must be either plus 1 or minus 1. So, this transition from 1s 1 by 2 to 1s 1 by 2 is not possible because it is not satisfying delta L. Okay, let us see even though it is satisfying delta J, half minus half, 0 only, it is not satisfying delta L. So this is not possible. Now let us see S 1 by 2 to P 3 by 2. Right? 1 S 1 by 2 to 2P 3 by 2. Now P means 1. S means 0. N equal to 3 to 2 no. S to P no. So, S means 0 minus 1. I think you understood. S is equal to 0. P is equal to 1. No. 0 minus 1 minus 1. Right? Here delta L value plus or minus 1 he said. So, minus 1. Here delta L value is minus 1. Alright. Now, next let us check delta J value. 1 by 2 minus 3 by 2. Now, okay, this is NP I am writing, not possible. Now, next I am checking this. 1 by 2 minus 3 by 2. What will be there? 1 minus 3 by 2 minus 2 by 2, that is minus 1. Delta J what we got? Minus 1. Here you see delta J must be equal to plus or minus 1. So, this is also possible. So, first transition 1 S 1 by 2 to 2P 3 by 2 is possible. right? The first transition. Now next let us check it. For possible I am writing P. So S minus P, 0 minus P, 1 minus 1. So L satisfied. Now next 1 by 2 minus 1 by 2, J value 0. Here you can have J value. So this is also possible. The second one, 1S 1 by 2 to 2P 3 by 2 is also possible. Alright. Now next, let us move for this one completed. Now here, the first transition out of 15, what we said? P 3 by 2. Now forget about this multiplicities. P 3 by 2 to S 1 by 2. Whether it is possible or not, let us see. First, let us check these J values. So 3 by 2 minus 1 by 2. So 2 by 2, that is plus 1. So plus 1 is there. So delta J is possible. Now P means 1. 1 minus next P to S, no, 0. 1 minus 0 plus 1. So delta J as well as delta L, both are there. So this transition is possible. So P 3 by 2 to S 1 by 2 is possible. Now next let us see whether P 3 by 2 to P 3 by 2 is possible. P 1 minus 1 0, but the delta L is not having 0, no. So it is not possible, right? Now next P 3 by 2 to P 1 by 2, let us see. Now P to P, no. Is it possible? Impossible. 1 minus 1 0. So this is also not possible, right? Now next let us go for this term. Again P 1 by 2 to S 1 by 2. 1 by 2, 1 by 2, delta J 0, possible. Now P and S are there. So 1 minus 0, 1. So this is possible. So P 1 by 2 to S 1 by 2 is possible. Now next let us go for P 1 by 2 to P 3 by 2. So now first P to P, 0, not possible. Similarly, P 1 by 2 to 1 by 2, again P to P, not possible, right? Now next let us move for this. D 5 by 2 to S 1 by 2. So first D to S, D to S 0, 2 minus 0, 2. But L value must be either plus 1 or minus 1. But here we are getting 2. So this is not possible. Now next let us go for D 5 by 2 to P 3 by 2. So first D to P, 2 minus 1. So delta L is possible. Plus 1 we got. Now next here, now let us go for J value. 5 by 2 minus 3 by 2. 2 by 2, that is plus 1. So this is possible. Delta J plus 1 is there. So now this is possible. Fifth one, D 5 by 2 to P 3 by 2 are possible. Right? Now let us move for this. D 5 by 2 minus P 1 by 2. So D to P, it is possible. 2 minus 1, 1. Now 5 by 2 minus 1 by 2, how much it will be there? 4 by 2, answer will be 2. It is not possible. Right? Now let us move for this last one. D 3 by 2 to 1 by 2. D 3 by 2 to S 1 by 2. Now D to S. D is to S is 0. Is it possible? 2 minus 0, 2. Delta L must be plus 1 or minus 1. So it is not possible. Now let us go for D 3 by 2 to P 3 by 2. Alright. Now D to P 2 minus 1. So delta L is possible plus 1. Now delta J 3 by 2 minus 3 by 2 0. So delta J must be either 0 or plus or minus 1. So this is possible. So D 3 by 2 to P 3 by 2 is possible. Now next last one D 3 by 2 to P 1 by 2. Delta L is possible. D is 2. P is 1. L value. So 1. It is possible plus 1. Now delta J 3 by 2 minus 1 by 2. So 3 minus 1 by 2, that is 2 by 2 plus 1. So this is also possible. D 3 by 2 to P 1 by 2 is possible. So theoretically we got 15 transitions here. See, theoretically how many must be there? 15 transitions must be there. But based on selection rule, only 7 transitions are possible. How many transitions are possible? Only 7 transitions are possible based on selection rules. And again, in these 7 transitions, 2 are identical. So how? What are that 2 means? One is D 3 by 2 to P 1 by 2. And next P 3 by 2 to S 1 by 2. This one. Next D 3 by 2 to P 1 by 2. P 3 by 2 to S 1 by 2. Next you see P 1 by 2 to S 1 by 2. This one. Next S 1 by 2 to this one. D 3 by 2 to P 3 by 2. In these 2 cases you see PS DP. So L value is unity. P means 1, S means 0. 1 minus 0, 1. D means 2, P means 1. 2 minus 1, 1. L value is unity and J values 1 by 2, 1 by 2, 1 by 2, 1 by 2. J values are same. So these are identical to each other. So now by removing these 2 identical values, only now 5 transitions are allowed in H alpha lines. So in such a way, we will write based on selection rule, we will write the transitions. Now let us take the example of sodium D line. Alright, the fine structure of sodium D line. So sodium D line we will get due to the electron transition from P to S state. Right? First let us write the P states spectral terms. P means what? 1. Now J will be L plus or minus S. 1 plus or minus half. So if you do plus, you will get 3 by 2. If you do minus, you will get 1 by 2. Similarly, so now 1 means what? P. First j values to the right side subscript and multiplicity 2s plus 1. 2 1 by 2 plus 1. 2 strikes off 1 plus 1 2. And for second, same L equal to 1 or 2p 1 by 2. Similarly, let us write for S state. For S state, L will be 0. J equal to L plus or minus S. 0 plus or minus half. Answer will be half itself only. So multiplicity as usual half no 2. 0 means what? S and spectral term. Correct? Now transition how we will write? This is S. P2 you are having. Right? Now here first 1 by 2. 1 by 2 and for P 1 by 2 3 by 2. Let us see. First 1 by 2 to 1 by 2. J 0 possible. P minus 1 minus 0 possible. Right? Selection rules I am applying. Selection rule delta L plus or minus 1 delta J either 0 or plus or minus 1. Now next one 3 by 2 to 1 by 2. What will be 3 by 2 minus 1 by 2? 2 by 2 plus 1. Possible J value. And S value 1 minus 0 1. So this is also possible. So in such a way we will write the splitting of spectral lines. Hope you understood my class. If you like my video, subscribe it, share it. Thank you for watching. Yours Reshma Physics.